While the domain layer is the safe center of an app which is independent of other layers, the data layer is a place where the app meets with the harsh outside world of APIs and third-party libraries. It consists of low-level data sources, repositories which are the single source of truth for the data, and finally, models. Hello, welcome to ResoCoder, where you are getting prepared for real app development by building better, faster, more stable apps. So subscribe and hit the bell if you want to grow your coding skills. You may have noticed that we always start working from the inner parts of the app and work our way toward the outskirts. After all, we started with the completely independent domain, and even there we first started with the most center thing which there is, and that's the entity. Now we are going to start with the model and only then go ahead and implement the repository and the low-level data sources. Why is that? Well, the entire clean architecture is predicated on one basic principle, and that is that the outer layers depend on inner layers, as you can see signified by those vertical lines on the diagram, which is right now on the screen. So it makes sense to start at the center, because otherwise we would have really a hard time implementing, for example, the use cases if we did not have any entities with which these use cases could work, right? And the same thing applies to the data layer. We cannot start working with the repository or the data sources, which get data either from the API or from local cache, before we have some models which can convert that data from or to JSON. Because after all, the API will return only a JSON string as the response, and we will have to parse it into some manageable Dart object. And be sure to check out the written tutorial from the link in the description, where you can find all of the code written in this video and go through all of the explanation at your own pace. Going from the center of the architecture outwards is only possible because we are using contracts, which in this case are abstract classes because we are in Dart, and Dart doesn't have the concept of an explicit interface. But regardless of how it's called, we define contracts, and that allow us to progress from the center outwards. Because think about it, we have these get concrete number trivia and also get random number trivia use cases already fully implemented, and yet all that we are working with is only a contract of the repository, right? This repository does not do anything real yet. All we did is that we mocked it inside the tests. And speaking of repository, we already know because of the contract how its public-facing interface will look like. It will have two methods, get concrete number trivia, which accepts an integer, and then get random number trivia. And this interface must be fulfilled by the implementation of the repository, which is actually going to do something useful. And this way, by implementing the interface, the use cases can really not care what's going on behind the scenes in the repository, as long as it fulfills its number trivia repository contract or interface. They're all cool. But of course, the data inside the repository, which it should then subsequently pass over to the use cases, cannot just be pulled out of thin air. So before creating the repository implementation, we will have to make the remote and local data sources first. And again, we are not going to create their implementations right away. We're going to create just the contracts of the remote and local data sources, similar to how we first created a contract for the repository. But before we can do even that, we have to take care of another thing, and that is a model. Why do we even need a model? Because we already have number trivia entities, so isn't this enough? As I've already briefly explained in a few previous parts, the domain layer should really be completely independent of any outside forces. So that includes JSON serialization and deserialization. Because what if we decide that we no longer want to work with a JSON API, but instead choose an XML API, right? What's going to happen then? We would have to touch the entity which is inside the domain layer here. We would need to touch this class, just because we've changed the outside interface, so to say, from JSON to XML. But when you think about it, switching from JSON to XML doesn't really change anything we are interested in the domain layer. It doesn't change the data held inside number trivia. It only changes the mechanism by which we convert some raw data, either JSON or XML, into Dart objects. And this kind of functionality should really not go into the domain layer, but instead into the data layer. And inside the data layer, we are not going to have entities, but we are going to have models which extend entities and add some additional functionality like the conversion from JSON and to JSON on top of those entities. You may have heard the word logic come out of my mouth, and that should immediately start blinking red lights in your head, because logic means we're gonna have to implement the models doing test-driven development, because we cannot write any logic without writing the test for it first. That's the core tenet of TDD after all. So let's go ahead and create a file for the model first under the features, number trivia, data, models. It will be called number trivia model.dart, of course. And also let's create an accompanying test for it, which will be under the mirrored location, so to say. So under number trivia feature data, let's create a new folder models. And we are going to create a new file, number trivia model underscore test.dart. Let's just import Flutter test.dart, and let's start off in the void main. The first test will be kind of a special one, because here it's really necessary that the model will extend the entity class. So number trivia model should subclass the number trivia entity. And we're going to test that with a special matcher. But first, let's create a number trivia model, which will be used for all of the tests inside this file. So we will prefix it with T for test. So T number trivia model. And it's gonna be equal to number trivia model. Of course, this is not gonna compile it because we do not have that class. And we're going to be able to set a number on it, just like on the number trivia entity classes. So number will be 1, for example, and text will be test text. Of course, this is not going to yet work, but let's continue on with the actual test. So we want to test that it should be a subclass of number trivia entity. Or actually, it's not called like that, it's just number trivia, and entity is just what it is. In this test, it's enough to leave in the assert part of the arrange, act, assert paradigm of testing. And all we want to check for here is that we expect the T number trivia model to be of type, so is a, and it should be a number trivia. So let's import number trivia here, and we can just, for the fun of it, run this test, but it's obviously going to fail because like it doesn't even compile. So that's kind of obvious. So let's try and implement this test. We're going to go over to number trivia model, and let's create a new class, number trivia model, which will extend number trivia. So let's import number trivia here, and inside its constructor, so number trivia model, we'll want to take in the number and the text. So let's just take in the text first, maybe. It will be a required named parameter, so let's put the required annotation here, and we therefore need to import meta.dart, so required string text, and then also required int number. And we do not want to do anything special with these two parameters inside the constructor. We just want to pass them over to the super class, so to the super constructor of number trivia entity. So text will be text and number will be number. All right, now when we try to run the test after we import number trivia model, of course, so now when we run it, it should pass just fine, and of course it does pass, so that's cool. The first actual conversion logic we're gonna implement will be the from JSON method, which should return a number trivia model instance with the same data as is present inside the JSON string, or basically not a string, it will accept a map of string dynamic. So it's already decoded JSON string. But we aren't going to test with the JSON string gotten from the, so to say, live API. Instead, we're gonna create a fixture, which is a regular just JSON file used for testing. That's because we want to have a predictable JSON string to test with. Because think about it, what if the JSON numbers API is under maintenance, right? Even in such case, we still want to be able to run our tests just fine. Or what if we do not have an internet connection? Under such circumstances, we still want those tests to pass, even though we cannot really access the remote API because there is no internet connection. If we go ahead and look at the JSON response from the API, and of course, link to that is in the written tutorial, to which you can get from the link in the video description, this is how the response looks like. There is a regular integer 181, for example, which is also present as the number field, and then there is the text field, which contains the actual trivia, and then two more fields in which we are completely not interested. But we have to watch out for some edge cases of the data which this API can return. And you should always watch for edge cases because that's where most of the problems stem from. If I refresh this enough times, hopefully I will be able to catch such an edge state. Here we go. So for example, this 1e plus 40 is the Eddington Dirac number. So what is this 1e plus 40? Well, this is just 10 to the power of 40, if I'm not mistaken, in this computery writing of exponents. But either way, regardless of what this number represents, it's really an integer. It doesn't contain any real decimal places, but the Dart compiler will regard this integer literal or number literal as a double, although it's really an integer. So we have to account even for numbers to appear like this one, which is really an integer, but it will be regarded as a double. We're now going to take these responses and freeze them in place, so to say, by creating two fixtures, trivia.json and also trivia.double.json file. So let's just copy this thing here and let's go to VS Code. Fixtures will go right into the core test folder. So let's create a new folder under test fixtures. And inside there, we are going to create new file, trivia.json. And let's paste this in here. As you can see, VS Code automatically somehow formatted this to remove the plus symbol from here. So it automatically just removes it for some reason. It doesn't really matter. But this trivia.json will not contain this crazy 1e plus 40 number. Instead, it will have just a regular 1, because we do not need these JSON fixtures to really represent real data. It just needs to have the proper structure. It doesn't need to contain actual strings which are present in the API. We can just, for example, say test text, and this will allow us to test with these fixtures more easily. So just always make sure that the structure of the response is always the same in the fixture as is in the real response, but the data can be, of course, simplified as we've done here. But we're going to create yet another fixture, which will be trivia double.json. And inside here, we again do not need to include this crazy 1e plus 40 just to make it into a double in Dart's eyes. Instead, we can just say something like 1.0. This is still technically an integer because this 0 doesn't do anything. It's still just 1, but the Dart compiler, when it sees it, it's gonna determine that, oh, this is a double, not an integer. So we will arrive in the same situation and we do not need to add any exponents over here or any such craziness. And again, it will just say test text. Now that we have basically these fake JSON responses inside the two files, we're going to have to come up with a way to read these files, because after all, our test code for the model or for any other classes which we are going to test in the future parts, the test code cannot work with files. It needs to have strings. So we somehow need to read this file and output a string out of this content of the file. For that, we're going to create a Fixture Reader, which will be only a simple file containing a top level function. So let's create it under Fixtures, Fixture Reader, .dart, and inside here we're going to create just one string returning function called fixture, and it's going to accept a name of the file which should be read, so string name, and we're just going to simply return a file and the location which starts at the root folder of our whole project. So if you look at this, the root folder is this Clean Architecture TDD course in my case. So it's going to start here, and then we need to navigate over to test and fixtures, and then to the name of the fixture, which is gonna be passed into here, into this function. So let's actually first import Dart.io, and now the file will be located under test, fixtures, and interpolated name, and we want to read this file as string synchronously. That's all there is to reading the files as strings from our tests. So let's finally, with all of these fixtures and this fixture reader in place, do some more testing with the number trivia model. We're going to create a new group for the method from JSON, which, as is a custom in Dart, should take in a JSON map, which will be a map of string dynamic, and it should output the number trivia model instance. So let's test. AAA test should return a valid model when the JSON number is an integer. Because remember, in the edge case, so to say, the number will not be regarded as an integer, but as a double. And that test will come next. But let's first deal with this simpler case where the Dart compiler doesn't do us any craziness. So in the arrange part, we want to get the fixture to simulate the JSON and convert it to a map string dynamic. So final map string dynamic JSON map, and it's gonna be equal to JSON.decode because we wanna convert a string to this map string dynamic. So this comes from the Dart convert library, JSON decode, and we want to obtain a string from the fixture which we have just created. So let's import Fixture Reader.dart, all right. And the name of the fixture will be the one which contains a number as an integer. So that's just the simple trivia.json. So it's this one. we want to get this and convert it to a string using this Fixture Reader, and then convert it to a map string dynamic using JSON decode. So now we have a JSON map which mimics the actual data which we will get by using the HTTP package by calling the actual live API endpoint. But we aren't calling anything. We are completely within the constraints of our own app. We aren't reaching out to any outside forces. So that's definitely a good thing. You never want to reach to some outside world from within your unit tests, which are for TDD. When it comes to integration tests and all of that stuff, now we're talking a bit differently. But when it comes to unit tests, you should really just test the unit which you should be testing and not really communicate with anything outside of it. So now let's store a result of the from JSON call inside this variable. So we want to call number trivia model dot from JSON. Of course, this is not going to work because we do not have this from JSON method yet. So we want to pass in the JSON map and we want to expect that the result is the same as the number trivia model. We could also say equals. That would be exactly the same thing. But whenever you just want to say equals, you can always omit it and just place the actual variable to which it should be equal directly inside the expect method. Again, there is no point in running this test because we know it's going to fail because it doesn't even compile yet. So let's go straight off to the number trivia model implementation and let's add the from JSON method, or in this case, it's gonna be actually a factory. So we are going to add a factory number trivia model dot from JSON, which will accept map string dynamic, and it's gonna be called JSON. And here we want to return simply a new number trivia model, which will get its text from the JSON map under the key text. And similarly, the number will be from the key of number. All right. And now, once we run the test, it should pass just fine. And surely the first test of the from JSON group passes. But now we will come to the next test, which is dealing with the pesky edge case where the number will be regarded as a double and not an integer. So let's just copy this test, which we already have here. We're going to paste it below and we're going to change a few things in it. So should return a valid model when the JSON number is regarded as a double. And now we're no longer going to get trivia.json, but trivia_double.json, and the rest can stay as it is now. So let's run the test again, and it's not going to pass because it says here that type double is not a subtype of type int. So we have a casting error. Let's take a look at that. We're going to go to the implementation of number trivia model.dart, and the problem happens right over at this line where we are dealing with the number. So what's happening here? Well, the number is dynamic, but this dynamic type will want to be cast into a number field of the number trivia model, which is of type integer. And whenever such an implicit cast happens, Dart will first determine the type of the dynamic value, because even though it's dynamic, it in fact really has some underlying type. In this case, it's a double. And what's gonna happen is that an implicit cast from double to an int fails. So we have to make an explicit cast or explicit conversion. First, we cannot just say to int directly like this, because this is dynamic, it's not really a double. but we cannot first cast this dynamic to double, because what's gonna happen, so as double, is that when this number is in fact an integer, which is gonna happen with this first fixture, for example, right? So trivia.json here, this first fixture, the number is not double, it's really an integer. And after I've run the test with this as double cast here, you can see that now the second test passes, so that's cool, but the first test does not pass, because now it says that type int is not a subtype of double. So we have a reverse problem, right? Similar to how you cannot cast a double to an integer, you cannot cast an integer to a double. So what can we do here? Well, thankfully, really thankfully, Dart has a data type, a basic data type called num. And num can be both an integer and also a double. And because of that, no matter what this number is in reality, casting it to num will always succeed, and then we can always convert it to an integer. So once we run this, all of the tests will pass. And that's definitely a good thing to see. So now we have the from JSON completely successfully implemented, and we can move on to the to JSON method, which will be actually a bit simpler because there is no integers or doubles to worry about, because we control data which is converted to JSON, whereas the data converted from JSON is not controlled by us. So we have to do some more testing with that, but to JSON will be a lot simpler. So again, let's create a group, to JSON, and inside this group we're going to have a test that to JSON should return a JSON map containing the proper data. So what's gonna actually happen here? In the arrange, we are not going to have anything because there is nothing to arrange, or you could say that we have already arranged something because we already have the t-number trivia model variable up top of the main method. But anyway, we are just going to act on the t-number trivia model instance, and we want to call to JSON, which is going to of course fail because there is no such method yet, and we're going to put the result into its own variable. And now let's assert that the result is expected to be a map, and let's go over to the trivia.json to see what it should contain. So it should contain text and number fields, because the two other fields are not actually gonna be converted to JSON because they are not present in the model nor in the entity. They are completely ignored. So we can copy just these two fields, text and number, and this should be present inside the map. But this is not all that readable, so let's actually get this map out of here and put it inside its own variable, final expected map. And it's gonna be equal to precisely that map, and we can expect that the result is the expected map, of course. And now running the test will of course fail because there is no toJSON method. So let's go ahead and implement it right now. toJSON will be only a simple instance method, so it's gonna return map string dynamic. We can copy it from here, toJSON, and let's just return a map containing text, which will be text from the text field of the class, and similarly number, which will be from the number field. All right. And once we run this, it should of course pass, and it does. So from JSON is successfully implemented, toJSON is successfully implemented, and also we can be sure that the model is a subclass of the entity. To go through this tutorial at your own pace once again, and also to get all of the code written in this video, check out the written tutorial available from the link in the video description. Now that we have the model in place, which can be converted from and to JSON, we are going to start working on the repository implementation and also on the data source contracts. And if you do not want to miss that part and also more tutorials like this, definitely subscribe to this channel and also join the notification squad by hitting the bell button to make sure you grow your Flutter coding skills, because here on ResoCoder, I am determined to provide you with the best app development tutorials and resources out there. If this video helped you some more with the test-driven development process and also with the clean architecture, give it a like and also share it with other developers who will surely benefit from it too. Leave a comment if you have any questions, follow me on Instagram, I go under the name ResoCoder everywhere, and see you in the next video.